let's look at this neutralization reaction. A neutralization reaction is a type of double replacement reaction. This is an acid, it begins with H. This is a base, it's a hydroxide, and we know it's one of our strong bases. This is a strong acid, it's one of the 6 we learned, and this is a strong base. Okay, so it's a double replacement reaction. I'm going to just make my molecular equation out of this one instead of writing it below. Double replacement means the positive part of one goes with the negative part of the other. So the front part of this one with the back part of that one. I need to check the charges and make sure I'm writing a neutral compound. So on this one I need 2 potassiums there. Okay, and then for my other product, the front part of this one with the back part of that one will give me water. I need to balance this. I have 2 potassiums, so I needed 2 here, 2 hydroxides. I'm balancing the polyatomic ions this time. So 2 hydroxides, I needed 2 here. That gives me 2 hydrogen ions, which I have 2 there, and 1 sulfate, 1 sulfate. So it looks balanced. Let's go ahead and put some state symbols on these. Potassium sulfate I know is water soluble because of the potassium. Water is not an electrolyte, and we don't say it's water soluble. It is just the liquid water. Okay, so next, when we do the complete ionic equation, we're going to take everything that is a strong electrolyte or breaks apart in water and break it apart. So starting up here with my sulfuric acid, I've got, it's one of our 6 strong ones, so I break it apart. Everything needs to have its charge and the aqueous symbol. Okay, and then my products. And then the water I don't split apart because it does not ionize. It's a molecular compound. Okay, and if I check at this point, everything should still be balanced if I've done everything correctly. Okay, now to go to the net ionic equation, I'm going to look for anything that is the same both before and after the reaction. So like this potassium, there are 2 ions before, 2 ions after. Let's see, what else? The sulfate. Okay, these that I just circled are it's kind of like they cancel out. Those are the spectator ions. Forgot to bring down my 2 on my water. So let's bring down the things that did not, that did react. And I didn't do the state symbols yet because we can see we're going to need to reduce that. These 2's, let's go ahead and reduce. Okay, and here's an important thing I want you to know, is that if a neutralization reaction involves a strong acid and a strong base, this will be the net ionic equation. Everything else will drop out. So that can help you. It can save you time, because if you look at the reactants and you see it's a strong acid and strong base, then you don't have to do all these steps if all you want is the net ionic. Strong acid plus strong base is always hydrogen ion plus hydroxide ion equals water.